22 says we have a large circle and centered at C and a smaller circle centered at D. And we can see by the diagram that the diameter of the circle, the smaller circle, is exactly half the diameter of the larger circle. We're given one measurement, which is 18 here, and we're asked to find the length of A to E, so this length here. So what we're going to do is use the properties of similar triangles here to work out some lengths. So if I take a look at this circle here, it's 18 across, so we know that this is going to be exactly 9 to the center, and then across here will be 9, which makes this 4.5 and 4.5. Okay, so we're going to use some lengths here like this. And we can see that this length here is going to be the same because it is a radius, so it's 4.5. So I'm just going to draw two triangles here and just kind of draw it out. So I've got two similar triangles. Okay, one triangle here, and the lengths of these triangles are going to be 13.5 along the hypotenuse and 4.5 here. This is the length of the radius. And I've got another similar triangle out here. Okay, so if I draw that, I'm just going to sketch that like this and give it some lengths. So the length along here is the length that I actually want. This length here is going to be A to E, and this length along here is the 18 centimeters that was given to us at the very beginning. Okay, this is B to E here. And I can see that these are similar triangles, so I'm going to use a similar triangle proportion to be able to solve for B to E. So I'm going to write B to E compares to 4.5 as the hypotenuse, 18 compares to the hypotenuse, 13.5. And I can see that there is a multiplying factor of times 3 here. Okay, so we can divide by 3 and we get BE. The length of BE is equal to 6. So there's lots of ways we could have solved this. We can see that this is in a ratio of 18 to 13.5 is 4 to 3. And if we do a 4 to 3 ratio for BE and 4.5, we still get BE equals 6. So key then is to work out that length of BE as a proportion, as a similar triangle proportion. Once I get that, now I can just apply Pythagoras to this problem to solve for the length of A to E. So I know that AE squared is equal to 18 squared minus the shorter side squared. And so we get AE is equal to, so AE squared is equal to 324 minus 36. AE squared is 288. Solving for A to E, we square root that, we get plus minus square root of 288. And we can just simplify that. So I'm going to take, since it's the length, I'm going to take away the plus minus and just say that this is a length of 288. Perfect square factor is 144. So I take out the 144 outside the root, and we're left with the times 2 inside the root.